So I thought I'd run through this last example in case my video cut out or in case you missed class. The goal here is to write the equation of a parabola that has a specific vertex and a specific point. The other examples on the previous page include a picture. This example is a little bit more challenging because there is no picture, so we just have to make our own very brief sketch, which is going to look at something like this. We're going to have, of course, an x and a y plane. And the vertex of the parabola should be at 2, 1. So I'll go ahead and mark that on my picture. It doesn't even need to be terribly accurate. It just needs, I need to know that that's the vertex at 2, 1. And then some other point at 4, negative 2. So I'll go ahead and plot that down here as well. And I know that I'm looking for a parabola that's doing this kind, it's going to hit this point, have that as a vertex, and go back down. And the goal, of course, is to find an equation that has that parabola. So the next thing I got to do is figure out how to change this pen color because I do not like writing in red. It makes me angry. All right, I did it. It's blue now. So we know from our previous work that the generic version of a parabola, if I know the shifts, is something like y equals, we don't know this value, xh squared plus k, and we know that this number inside here affects the left or right motion. This number out here affects the up or down motion, and this inside thing works the opposite the way you would assume. So if we're going to go 2 to the right, this is actually a negative 2, and this will be a positive 1. So let me explain that a little more clearly. Based on the fact that I know that this parabola has gone 2 to the right and up 1, I know the equation is something like y equals x minus 2 squared plus 1. But I don't know what that a value is. I pretty much have the equation right here. I just don't know the a value. So here's where I'll go ahead and grab this other point. I know this point has the coordinates 4, negative 2. So this is the x, this is the y. So I'm going to take this equation that I got based off of shifts. I'm going to replace the y with the y value and the x with the x value. So that's going to look something like this is the y value equals I don't know what. This is the x value plus 1. And now it's a matter of going back to like 5th grade math, 6th grade math, maybe 7th grade math. We have to simplify this side of the equation, and then we're going to solve. So we're using stuff from freshman year. We're using stuff from middle school. What we're using, in fact, is our good old friend, order of operations, PEMDAS. Maybe you learned it as Please Excuse My Dear Aunt Sally. It goes by a lot of other names, I'm sure. There's an equation here now. So we have like it, there's like a line through the equal sign, and we want to get this a to be all by itself eventually. But before I even worry about that, I've got to simplify. So this looks hideous because it's not simplified. When I'm simplifying, I'm doing PEMDAS starting this way and moving down. That means that I'm starting by looking at in this parentheses. We'll do that calculation. 4 minus 2, of course, is 2. So I have a 2 squared plus 1. The next thing after parentheses is to take care of exponents. So I'm looking, I'm scanning for exponents. Here I see exponents, and 2 squared is 4. Now, here's the thing I said in class. This is going to turn into a 4, but I'm not going to write down a times 4 because that just looks weird. You know, I'm going to write 4a because usually when we multiply a number by a variable, we put the number first. So these two guys are stuck together because they are multiplied. 2 squared does make 4, so that becomes 4a. This plus 1 is still here. This negative 2 is here. Now, this side is as simple as can be. This side can be no more simple. It's as simple as it can be. All like terms are combined. All parentheses are gone. All exponents are gone. I can't do anything else to it. I'm ready to solve. When we solve, we're doing PEMDAS, but we're doing it backwards because we're undoing what was done. So what we want to do there is start at the bottom and work our way up. And the goal here is to get this a to be by itself. So all my energy is focused over here, and I'm asking myself, is there anything to add or subtract? And of course, I can subtract 1 and subtract 1. So these cancel out. These guys, negative 2 and negative 1, they're friends. They're both negative. They get along. When they get along, there's 3 of them, and they're all negative. So negative 3 makes a 4a. And then I say to myself, is a by itself yet on this side of the equation? If I look at this side of the wall, is a alone? It is not alone. It's being multiplied by 4. So the opposite of multiplying by 4 is dividing by 4 and dividing by 4. Now the sad thing is this doesn't go in evenly. So I want to leave it just like that. Just leave it as a fraction. A equals negative 3/4. So what have I figured out exactly? What I figured out is at the very beginning, the whole goal is to try to write the equation of this parabola. And I almost had the whole equation right at the very beginning. I knew it was 2 to the right. I knew it was up 1. I just didn't know what it had to stretch by. But thanks to all this algebra, I know that a equals negative 3/4. I'm going to take this number and plop it in right here. So my final answer in beautiful fuchsia would be y equals that a value that I just found times x minus 2 squared plus 1. That's how these all are going to go. Final summary, we're going to start off by recognizing how the shifts work and use those shifts to get most of the equation. We're going to use that other point to find a value for y and for x to plug in. And then we're going to do a whole bunch of algebra to try and get that a value by itself so I can go back to the very beginning with that a value and have it all squared away. So I hope that makes sense. And if it doesn't, I have office hours. There's a math tutor. You can email me. You can IM me. There's like a million ways. So that's all I got. I hope that helps. And you guys have a great rest of your day.